Welcome to Procedural Content Generation. Let's talk about generative AI, what it is and why we should care. Let's start with a common function description. So this y equals f of x. If we look at a specific instance of this, say for instance the sine function, we can see that it takes a single parameter, which usually is time, and we get an output value. So there's this set call of a procedure, and it's parameterized by some inputs, and we receive content as output. So back to the basic function, you can basically model anything with this function f. So let's call it generate building. And if we change to that, what we can see is that we can add parameters to that function. So the number of floors, say, and we get some content as output. The generate building function can be arbitrarily complex, and it can be parameterized by any number of parameters. It's important to recognize that any content can be modeled by this function f. Usually we want to model a specific distribution of values to recreate our chosen content, so images or text or anything. So generative AI uses machine learning to generate content, and it's important you understand that that content can be anything. So it's been called a universal function approximator. And the idea is that it models any function that can take this form, y equals f of x, and it learns to approximate any function of f. So unless you've been living under a rock for the last few years, you'll probably notice that there's quite a lot of generative AI going around.
Generative AI is a new computing platform like PC, internet, mobile, and cloud.
And generative AI is one of these things where you kind of have to explore it to understand it, I suppose. And I've spent the last few years really getting into grips with generating using different machine learning models and trying to understand the sort of, I guess, the value in the procedural content realm for generative AI. And I think it's worth discussing that now.
Now we're going to do something extremely fun. We're going to play a wonderful game called
image generation. So for quite a while, there was a very popular form of model called a Generative Adversarial Network, or GAN for short. And they used two models, not that kind of model. They used two models, and one was the generator and another one was a discriminator, and they were trained adversarial, so they trained against each other. So the basic idea is relatively simple in that you have these two models, one that's generating content and the other one's trying to discriminate whether it's fake or not. And the generator tries to improve so that it fools the discriminator. The discriminator tries to get improve so that it's able to spot whether something's fake or not. The problem with that is that if one of them gets better faster than the other, you end up with a thing called mode collapse, where the generator is better than the discriminator and just becomes too good for it. Or conversely, the other way around, if the discriminator is able to always spot that it's fake, and you get this thing called mode collapse where they don't both improve over time. So the basic idea is that we're going to go through a loop, and the generator is going to generate an image. And the idea is that the discriminator looks at that image and comes up with a classification to say whether it's real or it's fake. And if the image is real, then obviously the discriminator gets a positive reward and the generator gets a negative reward because the generator wasn't able to fool the discriminator. And so the idea is that they keep going through these loops, and if the discriminator says it's fake and it's real, then the discriminator gets a negative reward and the generator gets a positive reward. And theoretically, they're supposed to be adversarially training. You know, they're getting better by competing with each other. That's the basic idea. But often they collapse. So there are a bunch of other types of GANs, and you can see some of them on the screen right now. Most of this is by research by NVIDIA, who are still relatively active in GAN-based works. And one of the reasons for that, this is the one called StyleGAN. One of the reasons for that is that GANs are kind of fast enough to edit in sort of semi-real time. So you can do a thing called a latent interpolation. So essentially use a sort of lower dimensional version of these images and interpolate across that for different types of features. So you can create edit interfaces. And this is a good example where you can kind of see that there's like similarities in the images, but you can kind of explore different, setups. So there's been a whole bunch of papers on GANs about sort of how to isolate individual features and how to change them, and things like adding glasses to a face and those kind of things. So I think NVIDIA are certainly onto something here in that we want real-time tools for editing, and they've actually been relatively good at producing these kind of tool sets. So a good example of this is what I'm going to show you in a second, which is this one called Canvas. And this came out of a GAN called GauGAN, and GauGAN 2 actually recently. And the idea was that you draw these semantic labels. So you can see on the left-hand side, there's these like single colored labels. They're just like arbitrary numbers essentially that denote what the type of thing is in the scene for the generator. So you can imagine that somebody with no artistic ability like me is quite sort of enamored of the idea that we can just paint kind of like, I want a tree kind of here, and the actual generator model will generate the tree or the sea. In this case, he's doing the sea. And so all it means is that it kind of translates some of the sort of basic concepts that you want as a creator into these kind of really quite compelling scenes. And obviously it's not like 100% ideal for like real artists, but for people who like me who are programmers, this is an actually ideal sort of setup. So think of tools when you're thinking of a lot of these generative models. That's where we're at. So there's other people been working on GANs, and this is an example of a relatively recent one called DragGAN. And you can try this online if you want to. This video's sped up a fair bit, but it's a relatively real-time tool set, and you can see that like in terms of an editing interface, it's kind of interesting. And what this kind of shows is just the power of like GANs as a sort of editing kind of tool, right? Because they're near enough real time that you can actually get some expressivity out of them. And I think that, tools like this are definitely going to be a big part of like games and creativity and sort of content creation in the future. Not just for images though, and something we're going to have a look at in a minute. So think about what kinds of tool sets you might want to sort of see about these kind of things, right? And they might use GANs. So diffusion models are these really interesting sort of things that took over really the sort of popular zeitgeist from the GANs. And you can go to OpenAI's webpage and see the original DALL-E paper. And the reason why it was really impressive was that because it was using text to derive a particular image. And that was like relatively new. And the actual important part of this research was this thing called CLIP, which was an encoder that another sort of neural network model that pushed the generation of an image towards a particular piece of text. So that the model was trained on image text pairs, hundreds of millions of them. And so CLIP was actually the really important part of this. And you'll see that there's an open CLIP now as well, where it's like more open source. So that was really important for diffusion. So there's a great website called the Diffusion Explainer, and you can see the URL at the top of the screen. But the idea would be that the basic notion of diffusion is that we take an image and we add some noise to it in a sequence of steps, and then we train a machine learning model to reverse those steps. And over, hundreds of millions of images, the machine learning model realizes how to denoise a particular step of, basically noisy information. And then we use this CLIP encoding, this sort of text, the correlation between text and image. So we've trained the model to recognize the correlation between text and image. We use that to drive the image that we're generating from this noise towards a particular style of image. So you can see that the sort of clip encoding thing was really the most powerful feature of that. There's another thing that we'll talk about in a second, but ultimately this process is kind of like a stepwise refinement process from essentially pure noise at a start towards an image, and we're kind of just slowly nudging this noise towards the image in multiple steps. And when you come to actually play with these models, you'll see that there's lots and lots of things that you can sort of play with to get the kinds of images you want. So you can obviously read the website if you're interested. There's some interesting stuff here, things like the upscalers and units and all of that kind of stuff, but read the website for details about that. So probably the most sort of, I don't want to call it industry standard, but the most sort of popular artistic model right now is a thing called Midjourney, which is this like Discord bot interface thing. And you could tell that it's kind of been trained on lots of high quality aesthetic sort of images, but it's not a publicly available service, and we don't really know how it works. And there's a recent model called SDXL, which has kind of come out, has similar sort of qualities. But anyway, you can see the links in the video description for where these images were generated. And there's a few videos linked talking about Midjourney 5.1, 5.2, that kind of thing. So I would sort of recommend that you have a play with Midjourney just to sort of see what you can generate with it. But I really don't get along with its interface. And speaking of getting along with interfaces, I recommend this video by Matt Wolf. Matt Wolf sort of covers a lot of generative AI, and he did a really long video that looks at a whole bunch of different image generators and where they came from and what their interfaces are. I would definitely recommend this video if you're kind of interested. Plus, obviously, it shows you how to sign up, which ones you can sign up for and generate things for free. So it's well worth watching his video on this particular thing. So one of the most important features of things like Stable Diffusion that actually kind of make some of this open source stuff more possible is this idea of latent diffusion. And the basic idea is this: we take an image and we run it through a model that encodes it into a latent, what we call a latent vector, which is kind of like a low dimensional representation of the image. And the idea is that we should be able to take a decoder version of that and recreate the same image. And so the key sort of thing here is that, like, normally we would noise the image, but that's expensive because obviously we need to noise it, and that's, it's quite a sort of big dimension to do. So rather than doing the image as a noise, what the latent diffusion model did, and you can see the paper if you want to see the details, but what the latent diffusion model did was actually noise the latents. So it noised the low dimensional representation of it. And that's a really, really insightful thing to think about, right? We've taken this high dimensional object like an image and reduced its dimensions down and used that instead. So one of the key areas here is that, we've got these image generator models and they're really good, but we kind of need to be able to control them much better. And so there's this recent work on a thing called ControlNet, and you can try it out inside of Automatic 1111 and a bunch of other interfaces. But the idea here is that you've got this kind of setup where there's an initial model. On the left here, we've got the sort of neural network model, which is basically the image generator. And so what we want to be able to do is take this single model on the left, and we want to essentially piggyback another model. And this is the example on the right, where we've got a second model that's going to drive the first model's output. So essentially, it's kind of like a instructor model in a way, right? And so the idea is a relatively small model. So these ControlNet models are easily trainable by anybody. Is going to control a really big model. You can think of 500,000, 2 million, or whatever to train the basic like image generator model, right? So it's only going to be a big corporation that does that. But anybody can train these ControlNet models, and the ControlNet models are kind of a way of guiding the image generator models in a more sort of useful direction. And so what they add is a bunch of additional what we call conditioning that pushes the model to produce the kinds of things we want. And that's like generally useful, right? And usually it's for things like composition. So you can read the website. It's a GitHub repository. If you just look for ControlNet, you'll find it. But here we see exactly the types of things that you can do. So here's an example from their Gradio interface. And this is a thing called a canny edge detector. So essentially we give it an input image and it creates this thing called a canny edge detection. So essentially this sort of black and white image here, which is just detecting where the edges of the image are. And then we use that as a conditioning for the image generator to actually generate the same composition, but with different content. So you can see that the image that's produced looks like the initial bird image because it's controlling that sort of edge detection thing, right? So you get the objects in the same place and that kind of thing. And so if you look at the ControlNet website, you'll see there's a whole bunch of these different things, right? And you can see examples here. It's really useful to be able to get what you want in image generation. Like prior to this ControlNet coming out, it was really hard. And so this idea of like a small model guiding a much bigger one is actually a generally useful property of these like new generative AI models. And so you can see there's a whole bunch of different types of conditioning models that's driving a lot of this stuff. So here's the how detector, and there's a bunch of different things. You can do things like a sketch-based interface and just feed it a really crappy looking sketch, right? But you get good composition out of it. And so, sketch-based interfaces are a thing. You'll see that in Matt Wolf's video if you watch it. This is the one that I really like. This is the thing called Open Pose, where you really give it an input image and it generates this skeleton pose detection. So essentially it's a computer vision model that generates a skeleton. And if we feed that skeleton from the input image using the points generated from the pose estimator, we can feed that into the model as guidance and get a bunch of images that are output with the same pose. Now, if you think about it, that's a really useful thing to be able to do. And if you watch any people's videos on YouTube about sort of like actually generating with these text to image models, it's a really useful feature. And so, think about this as a sort of general purpose, like approach to creating tools, right? We have a small model that guides a much more powerful but almost impossible to train model, right? You couldn't, as a sort of individual user, train a text to image model, but you can train one of these control nets to guide one of these image models. And that's like a really powerful kind of theoretical foundation. Here's a depth model. There's a thing called Minas that extracts depth from images. So you can use like depth, and I use depth from Unreal Engine to guide my image generators. So I often use Unreal Engine as an input to my text-to-image model generators. So again, you can go to this ControlNet website and kind of read through how it works. You can read the academic paper that comes along with it. There's a link at the top there. Definitely have a play with it in Automatic 1111 just so you get a sort of intuition about how it's used. I recommend Olivia Sarikas's videos for this if you're interested in playing with it. So that's ControlNet, a really useful kind of conceptual thing to think about. So let's talk about this idea of open source models, because one of the things that's probably not obvious is that when I first started looking at a lot of these like text to image models, essentially they were operated and run by, huge tech giants, right? So this is a model called Imagen by Google, and Google have had a bunch of different models over the period. And think about sort of OpenAI, right? Massively well-funded research lab that did these text-to-image models, but even the first DALL-E wasn't available to anybody to use. So we were seeing these really like very powerful models, but of course nobody had access to them. You might if you work for the company or you were an insider, But actually, I think that's really problematic. We don't really want like mega corporations gatekeeping our, access to some of this technology. And so I think that one of the biggest things that's come out sort of in the last few years, because, if you look at the capability of these models, right, they're really, really powerful. And obviously, Google and OpenAI have been in kind of quite a bit of a war over like how to improve their models over the years. But we've seen like, rapid advancements, but off the back of really expensive like hardware requirements, like only companies at this scale could afford to do it. And so, some people at this company called Stability AI found, essentially convinced a bunch of bankers, venture capitalists to fund this idea of an open source version of it. So essentially they would purchase like, the GPU time and all of that kind of stuff and train a bunch of models, but then they would release the models for free to everybody. And that's like quite a powerful thing, right? Imagine you're spending a couple of million training a model. And this SDXL one is like really hot off the press, right? So they've just trained another version of their open source model that's much more powerful, kind of approaching the Mid-Journey thing, right? So people are paying Mid-Journey, paying monthly to generate more, images. And now we've got a new model that's kind of on par aesthetically, and it's all available for free. It's available to download. You can download the model weights and run it in a whole bunch of different ways. A thing called Automatic 1111 or Comfy UI, or you can use one of these cloud providers. But the main thing that's happening here is that because we've got open source models, we're seeing an ecosystem of sort of additional developers developing new interfaces and new websites and services and stuff on top of these open source models. And I think that that's one of the sort of more transformative even aspects of, the generative AI scene in general, right? Is that like there are a few people who are actually generating really high quality open source technology. And this isn't just images, Stability produce images, and through their offshoot called Harmon AI, they're doing like audio and music. So we're seeing this like generation of open source large models. And like I've been saying, I think that probably what we'll see is that we'll see like open source versions of these foundation models, and then lots and lots of custom trained ControlNet type models where we kind of push these models towards what we want. So if you're interested, you can see the research from their website. Essentially, they're, doing what everybody else is doing, right? Training these new models and what have you, and training things like upscalers and all of that kind of stuff. But open source, I think, is a really key reason why we're even discussing generative AI now. And so we're seeing this kind of push towards open source in the text-to-image generation space. And we're also seeing it in a bunch of other generative AI spaces like, text generation, the language modeling kind of stuff that we'll have a look at in a second. But so just think about that. We've got this capability of using these open source models, and we've got the capability of pushing them towards unique user interfaces and tools that we can generate with them. And that's the important part. So natural language models, the other sort of arm of generative AI right now, right, where everybody's kind of up in arms about it. I'm not going to talk about the usual ChatGPT stuff. Hopefully you've all kind of heard of ChatGPT and have a vague idea of it. What I'm going to talk about is this thing called Hugging Face, which is a website and a company that like develops and hosts machine learning models. So they've got this thing called Hugging Face Spaces, which is like the hosting part of it, but they've also got a bunch of libraries for hosting your own like machine learning models. So they've got this thing called the diffusers library that we'll maybe play with. But what's useful here is that these Hugging Face in particular host a whole bunch of different types of generative AI models. So if you're interested in like what the future of generative AI is, or at least sort of playing with some of the latest models, Hugging Face is usually the place to come to. And you can see here there's the Llama model, which is a relatively recent open source language model. This one's relatively small, right? So probably not as capable, but obviously there are like bigger models. You know, you can have a look at the 70 billion parameter one. The point here is that you would never be able to run this at home. The sort of amount of memory required to run these large language models is prohibitive, and the cost of generating one is, you know, like in the millions at least. So apparently OpenAI is spending something like £700,000 a week on GPU costs alone. So, you know, like this is no joke, right? And so even like you can see like SDSL, all of these sort of latest models are kind of available to us on Hugging Face, and even just sort of new tool sets. So this is one I use quite a lot called Comfy UI. It allows you to try out some of these models, and you can run all of these things on Hugging, or most of these things on Hugging Face locally if you've got a decent GPU. And so what I tend to do is play with it on Hugging Face, and if I like it, I'll install a local version of it. So you can see me like just generating an image here. The point being that like if we're saying that open source is the future, then the ecosystem of open source projects and communities is at least as important as the models themselves. And so I think Hugging Face is definitely like looking at the future here, right? So we've got a whole bunch of different types of open source models and interfaces and, you know, applications and kind of, you know, music generators and all image generators and all sorts of stuff. So I would highly recommend anybody who's interested in generative AI to look at Hugging Face as a really great resource to sort of see what the future is like, even if it's a little bit rough around the edges sometimes in terms of like hosting and having access and things not working, because obviously it costs a lot in terms of compute. So they have to ration the amount of compute power they give to people. But you can try some of these really big language models that are open source. You can like build your own applications. So things like they've got an open LLM, hard to say, an open language model, essentially a leaderboard, right? So there's so many language models coming out now, and especially open source ones that are, you know, like relatively small but much better trained than these really, really big models like ChatGPT. And so what I'm seeing is this leaderboard of a bunch of essentially a bunch of different benchmarks. So things like HelloSwag and, you know, the sort of instruction benchmarks and stuff. And so every model gets tested against these using the diffusers library usually. Not the diffusers library, the text generation library. And so what that means is that we can compare the capabilities of these different models and even compare them against, you know, like the ChatGPTs of the world, the GPT-4s and those kind of things. And obviously those companies are still expanding their capability as well. So in general, what we're looking at is a very wide ecosystem of different types of approaches. But my strong assertion is that open source is definitely going to be the most powerful version of this. And I think that is very worth you spending some time investigating just to get a feel for like what the value proposition is for some of these models, especially the smaller ones. So one of the most fun kind of generative AI aspects is the idea of AI generated video. And there's obviously a lot of significant challenges in video generation. One of the obvious ones being just the sheer amount of data that it requires to be trained on. And so there's companies like Pika Labs and Runway ML and a few others that are actually tackling this kind of thing. And I've put some links in the description. But you can see that they're still relatively wonky. Things like, dogs moving in reverse. But like there are also some pretty good ones where, like this one, they're using Midjourney as a sort of like a base model to then generate additional content from. And so what you'll actually see is that a lot of the best generated content has other models as part of its training, basically as sort of seed. So here's an example where you've taken a Midjourney prompt and used Gen 2, or you've taken an image from another package and used Gen 2 to sort of animate it. So like it's a really useful thing. And honestly, I kind of think that a lot of content will be generated, right? The especially media content. You imagine this kind of thing for, I don't know, weather reporting or stuff like that, right? It's not necessarily the high end that we need to think about. It's also the lower end of like creative media, website content and stuff like this. And people are already producing relatively good kind of short films. So this one's, again, linked in the description. I'm not going to play all of it, but you can kind of see that it's got this like Steinman Stallenhag vibe going on. And it still looks a bit wonky in places, but you can kind of get a narrative from it. And obviously with the music and voiceover and stuff, it actually is a lot more compelling rather than me just talking over it. So I suspect that these models will improve really rapidly as the sort of feature set, and obviously things like ControlNet will be part of these kind of models as well. So I think my current favorite generation of this like video generation thing is this one. And I came across this randomly on Twitter, I think, or maybe on LinkedIn. And again, the link's in the description, but you can kind of see, right, they're using Midjourney as a sort of base starting point and then adding additional stuff to it. So you can see that even like Hollywood films are going to start to employ some of this kind of generative AI. And I see that a lot in like commercial advertising and stuff already, right? Like we've already seen like film and movie trailers and stuff, TV and movie trailers, using generative AI as a sort of starting point. So it's not unusual to think that this might carry on. So the last bit I want to talk about is this idea of 3D model generation. And one of the sort of papers that's kind of most interesting is this one called Dream Fusion. So again, you can go and have a look on their website. I'll provide the links in the description. But this is kind of a pattern of things, right, where we're using models to implement other models and features and those kind of things. So it's kind of like the generative AI space is expanding out through, having access to models that can then lead to other types of generative content. And so this idea of Dream Fusion is a relatively simple one, right? Using, again, the diffusion process, but this time you're generating multiple views of the same object, and then you're using that to create a mesh from. So there's a thing called a neural radiance field that we use in graphics a fair bit, and that you can extract information from that. And there's actually a bunch of papers, a lot of them by Google, interestingly enough, that talk about sort of 3D mesh extraction from image generation and what have you. there's a whole bunch of different papers. If you look at like some of the big conferences, the AI conferences, you'll see a lot of these things. This is relatively rudimentary right now, but it's clearly going to get a lot better, and it's well worth kind of keeping an eye on this generative space. Because frankly, you know, if you're a programmer like I am, you just don't have the art skills to be able to produce your own art. But if we can generate it and, you know, have the generation sort of automatically create a skeleton and animate itself, and there's like text to animation and all of this kind of stuff. The point is that generative AI isn't one thing, right? It's a bunch of models that kind of propose new techniques and new ideas for us all, and new creative tools that we can use. So realistically, what I would suggest you do is that you go and try some of these different generation models. Most of them are on Hugging Face, available for you to play with, not always for free and not always available, but it's probably the best place to sort of get an intuition for this.